Hey guys, welcome to another episode of Online Learning with Miss Gutierrez. We are today going to be looking at lesson 109 in your books. This lesson is about equations with exponents. So this is just more of our solving equations, a process that you are already familiar with and doing great at. We're just tacking on one more little piece of the puzzle here. Matthew, I know you'll appreciate that with your puzzle building. So anyway, we're going to look at what this looks like when we're solving equations, what we need to do, because remember, when we're solving an equation, we are undoing things to try and get the variable by itself. So we are going to look at, okay, well, when I have an exponent being done to my variable, how do I undo that in order to get that variable by itself? Okay, so that is our objective today. And we're going to look at a few different examples, including some word problems that are going to kind of help us work through that and get really familiar with that. So let's go ahead and open up the first one. Okay, so here's an example of an equation that has an exponent on the x that we are being asked to solve for. So now we want, again, our goal is always to get x by itself when we're solving an equation, okay? So remember, I can split this down the middle and say what I do to one side, I'm going to do to both sides, okay? And I can still operate it just like I normally would. So normally you would look at this, even if that squared wasn't there, and you would say, okay, first I want to undo the subtraction, because remember, that is all based on our PEMDAS. When we are solving, we start at the bottom and work our way up. Okay, so if I see subtraction happening, that's going to be at the bottom. So I'm going to undo that first. I'm going to undo that by doing the opposite, which is to add 1, okay? Cancel my -1, and then 47 plus 1 would equal 48. So then I've still got 3x squared over here, okay? So then the next thing, that was subtraction. So then the next thing that I see happening is multiplication. That's the next thing if I'm working from the bottom to the top. So to undo multiplication, I have to divide. So I'm going to divide by 3. And that's going to get that 3 taken away from that left-hand side. Now 48 divided by 3, you could work that out, and that should give you 16. So now I know that x squared, all I have left is x squared equals 16. So now the question is, how do I unsquare something? Well, let's think about what is the opposite of squaring something. And you guys know this because we've already talked about this. So I know that right now the word going through your head or words is square root. That's right. So we can square root our x squared, and that would be the opposite. So that would cancel that squared out. But remember, if you square root one side, you have to square root the other side. Now, here's something that we've touched on, but we haven't talked a whole lot about. Remember, when you square root something, there are actually always 2 possible answers, okay? Because I know the square root of 16 is 4. But, and I know that because 4 times 4, let me write that over here for you. 4 times 4 equals 16. That's how I know that the square root of 16 is 4. But what about -4? What if I do -4 times -4? That also gives me a positive 16. So actually, I could have a result of +4, or I could have a result of -4, because both of those values squared equals a positive 16. Therefore, they both could be answers when we square root 16, okay? So in a problem like this, you will actually have 2 solutions, okay? Does everybody see that? Let's try another example. All right, so what if we've got 2x squared equals 10? So same process here. I see multiplication happening, so I'm going to undo that first by dividing by 2. Dividing by 2, so x squared equals 10 divided by 2 is 5. Now, again, x is still being squared. My goal is still to get x by itself. So to undo that, I have to square root both sides, okay? That is going to isolate my x, but small problem on this one. Do we know what the square root of 5 is? No, we don't have a whole number that is the square root of 5. So what we can do, though, is we can still say positive square root of 5 or negative square root of 5. Those are both possible answers here. So we want to make sure to include both of them. It is very important that you have the positive version and the negative version of the answer on these, okay? Let's look at another one. Okay, so this one says 5 less than what number squared is 20? Okay, if you're thinking keywords, you are on the right track. Let's look for those keywords. So we've got 5, which is a number, right? 5 less than. Remember, less than means subtraction, but remember to be careful with this because does it mean 5 minus the number squared or does it mean the number squared minus 5? So if you said the number squared minus 5, you would be correct. So the number squared, which we don't know what the number is, so we'll just call it x, okay? But the number squared minus 5 is how we would translate when it says 5 less than what number squared, okay? Then we see the word is. What does is tell us? If you said equal to, then you would be correct. So is equal to 20. Now we can solve. We've translated our word problem into an equation. So now let's get to solving. So the first thing we would do here is add the 5 because we want to undo that subtraction first. Remember, reverse PEMDAS. Okay, so that would give us 25. So we've got x squared equals 25. Now again, x is still being squared, so we want to undo that. So the opposite of squaring something is always to square root. And remember, when I square root, we have how many possible answers? Very good. 2 possible answers. We could have a positive 5 or a negative 5. Awesome job, guys. Two more examples and we're done. So close. Hang in there. All right, so let's look at the next one. This one's a little longer, so let's just kind of read carefully and think through it. In this figure, the area of the larger square is 4 square units, which is twice the area of the smaller square. What is the length of each side of the smaller square? So again, keywords. I want you to really pay attention here, though, to the fact that we are talking about area. It refers to area twice. The relationship that these squares have with each other is based on the area. So that asks the question, how do we find area of a square? First, we would say, what do we know about a square? We know all 4 sides are the same. Okay, so I'm going to use my inside square. So if this side is S, this side has to be S. Okay, they would all be S. Excuse me. So if that's the case, then when I find the area, remember area is just length times width, okay, which in this case are the same thing. It's S times S. Now, when we multiply something by itself, remember, we could also write that as S squared. So when I write my equation here to represent what's happening, I'm going to use S squared as the area for my smaller triangle, okay? So if I take the area of, square. If I take the area of my smaller square, which is S squared, okay, then I can look back and say, okay, the problem told me that the area of the larger square is 4 units, and that is twice the area of the smaller square. So that means that twice word tells me times 2. So that means I can multiply my smaller square area, which was S squared, times 2, and that would give me the area of the larger square, which they told us was 4. Okay, so hopefully you can see here how there are other keywords that I was able to kind of use to put this together, okay? But this is important. Being able to take that word problem and turn it into an equation is really important and helpful in the solving process. You've got to make an equation before you can solve for it, okay? So now I'm still solving for S, okay? So the first thing I want to do is undo that multiplication. So I'm going to divide by 2. So that would give me S squared equals 2. Now, S is still being squared. The only way to cancel that or to reverse that is to square root. Now, I don't know the square root of 2, but I do know that square root of positive 2 or square root of negative 2 are both possible answers. But let me ask you this. Is it possible to have a negative length of a side? It is not. So this one, because of the type of question here, because of the fact that we're talking about a quote unquote real world type thing, and reasonably we cannot have a negative length of a side, we are only going to go with the positive version of the answer here. Okay? So sometimes you just have to apply some reasoning to determine whether or not you need both answers, but both answers are always mathematically correct. It's just situationally, do both of them fit here and make sense, okay? Last one. So now we've got, this is our P word. It is a proportion. Very good. So with our proportion, we are solving for X again also. So with a proportion, we always cross multiply. Okay, so 3 times 12 is 36. X times X is X times itself. So that could be written as X squared. Okay, again, we see X being squared here. The only way to undo that is to square root. So that leaves X by itself. And we know the square root of 36 is 6, but it could also be negative 6. This is not a real world situation, so we don't have to really think about reasoning here. We can just say my answers could be positive 6 or negative 6. End of story. And that's it. So main message here on this lesson, if you have a variable being squared in an equation, to undo that, you do the square root. And keep in mind that when you square root a number, there is always a positive and negative version of the answer. All right, great job, guys. Happy homework.